Hey everyone, welcome back to the shop. I have some repair work that I need to get started on today. I've got some parts here behind me that goes to a cable winch system for a local construction company. A little over a year ago, they brought me a very similar unit that we did some work on. We had to do some drilling and tapping for set screws. And this is going to be a very similar, almost identical type job that we have to get done. This time they actually brought a shaft and a worm gear that needs a little bit of work too. So this is what I'm going to get started on. They called me and explained what the issue was with this. They were trying to get it apart to do some maintenance on it, and they just need a little bit of help getting these parts back in proper condition so they can put it all back together and get it back on the job site and put one of their crews back to work. So I'm going to get started on this and try to get it done as quickly as we can because I know they definitely need it, and I'm going to try to get some video of this to share with you on the channel today, all right? But we'll pull you in for a little tighter shot and I'll go over what we need to get done on these parts today. So we have 3 total parts here that need a little bit of work. We have our cable drum here, we have a worm gear, and then this is the shaft that both of these pieces go to. The main area of focus, honestly, is really with this cable drum here. And what they have here is 2 set screws that are completely frozen, rusted up inside here, that the hex is stripped out. There's no way you can get these guys to move. They really need to be drilled out. So that's what they asked me. Could we just drill these guys out and put some new set screws? If we roll this over, there's another one right here, same thing. So you have 2 of them opposing each other 180 degrees. But what I think we're gonna end up having to do is probably just drill and tap 2 new holes in this drum here. I can definitely line up on this hole, and that's what we're gonna do. But if you guys have never tried to drill a set screw out, let me tell you, it's not the most fun thing to do. Set screws are very hardened and they're very tough to drill. So if you're using conventional drills, high-speed steel drills, and you're trying to drill a set screw, you instantly dull it and it just gives you issues. You can definitely use carbide, but I don't like using carbide drills in manual drilling operations because all you're doing is asking for more trouble, and you end up chipping and breaking and tearing up expensive carbide tools. So I think the best solution would be to line up the 2 existing holes with our drills. All right, and because of where whoever made this is a very, very old unit, by the way. So whoever made this, they drilled and tapped these set screws. This hub, I know it's kind of hard to see. I got a little flashlight here, see if that'll help. Come on, there we go. The set screws are nearly towards the back end on the inside of that hub there. So we actually have enough room that we can just simply line up our hole and just move it back like into that position right there, and then drill it and tap it just like we did the previous drum, and then put some new set screws in there. So that's probably what we're going to do to try to eliminate any kind of problems messing up our drills and just further issues that we're dealing with seized up set screws down inside there. All right, so that's what we're going to do on this. We'll get this set up in the manual milling machine. We got to get some angle plates set up and be able to hang this off and clamp it up, but we'll show you all that. This is the worm gear. You've got a couple of keyways in there. This is the shaft, which the gear goes on, and then the pulley, the drum right here, goes up on the shaft right there. They said that they pressed it apart because they could not get the set screws to loosen up. So you can see the result of that. They were pushed down into the shaft pretty hard, and then they dug this channel, galled this channel in the shaft right, getting it out. So you've got some high spots on this groove here and on the other side as well. This one, I don't think it was touching very much at all, but we really just need to take and clean this up and get rid of the high spots where it deformed the diameter of the shaft. And then same thing on, so on this end here, this is where the worm gear slides on, double key. And they said that the key sheared. All right. I need to just clean up the bore, make sure the keyways are cleaned up. And they asked about welding this keyway up, both of them, and recutting it. My suggestion, to save time and aggravation, honestly, is to just mill two new keyways on this shaft right here. So that's what we'll do. We got to clean up this. You can see it's high right here, so we'll need to clean this up in the lathe, or you could use a file, either one, and clean this up so that you have a true diameter. And then we will just machine two new keys in this 180 so that it'll properly drive on that gear there. We're trying to do the minimal effort of this. I could definitely make a new shaft, and I threw that out as an option, and they asked if it's possible, just try to do the minimum work, use the existing shaft, and try to get this back in operation. So that's what we're going for here. Just try to get it done as quickly as we can and try to save a little bit of money on this. This is very, very old parts. This gear would most likely, you would have to have a shop that manufactures gears to make this. This is probably not a part that you're ever going to find on a shelf. So it's got wear on it. So they just want to get it back in operation. All right, so that's what we're going to work on. I'm going to start with this because this is going to be the biggest problem child of all this. We'll get this knocked out, and then we will focus on the gear and the shaft. First thing I'll start on is just simply getting this bore and these keyways cleaned out. I've got the bore cleaned out, the keyways are filed out, and then the set screws are now sticking out there. You can see, I think you can see that in the video. And I'm going to take a carbide ball burr and go in there and just grind that set screw down so that it's below the surface of the bore.
A little bit in the back.
All right, that feels good there. We'll do that on the other side. I've got this bore pretty well cleaned up, I believe. I've got the shaft. This is a 2-inch journal, by the way. I haven't done anything to the shaft yet, but if we line up that gall spot there with the key, I'm able to get it to slide in there to about right there. Starts getting a little bit tight, so we do have a little tight spot somewhere there on the shaft. So what I'm going to do next, I believe I have the bore good enough to go in the drum here. I'm going to go ahead and work on the shaft here and knock down the high spots from the galling there so that this will be finished and we can actually use this. This will help aid me in some of the setup because when I go to find the center of this, we can put the shaft in here and use an edge finder, find the center of the shaft whenever we go to do our drilling and tapping. So we'll go ahead and try to get this shaft cleaned up next. It's definitely high on this side right here. We'll just put it in a vise here and do some hand work on the shaft. Maybe do some filing on that. Let me see what it's like with a file. So our good area of the shaft, if we just get some general average dimensions, that's 1.5 over, that's 3 over right there. What's our journal fit at? 1 over. This is where our drum is going to be sitting, right in this general area. Looks like they got anywhere from 1/2 to 1 over. And then this area that we're filing, that's 8 thousandths over there. Just getting an idea how much it's sticking up. Yeah, that's almost 10 thou right there. So we definitely have plenty of filing and grinding to do right here. So I'm just going to keep working it. This mill smooth side of the file is doing a nice job. We have a coarse side here. Let's see what happens with that. That might be good too, to knock it down a little faster. Tell you what, let's rotate it. Let's go ahead and make sure that this side isn't hanging us up. And we'll go ahead, there's a very minor gall groove right there. We'll go ahead and file that one down. And where the set screw is hitting, that looks good, that feels good. Go back to our other side. And I'll just keep working it. I think we've got this bore cleaned up and the shaft to where they can go together. So we did our filing down this groove here, cleaned up both sides of it. And it'll go through there. And then where the two keys are, I haven't cleaned that up yet, but you see it's trying to go in there. So right now it's just hitting on either side of these double keys here. So that needs to be filed next, but I think we've got our bore in a pretty good state. So a little bit more work to do on the shaft here, and I think that'll all fit together the way it's supposed to. I think I got this guy cleaned up to where the shaft will slide in there now. Right there. It's in there. So That'll work. Now I can put this in there and we can locate on our shaft. We know that it's going to fit in there like it's supposed to. So at least that part of it's done. Now I still have to work on these two keys right here, and I'm going to work on that later. I'm just kind of focusing on this part of the job right now. Okay, we have moved over to the KBC mill. I'm beginning to get it set up now. Just wanted to show you where I'm at. This gets a little finicky right here on something like this. I did use the jib crane there to pick it up and hold it in place. And I just wanted to kind of give you my setup, and then I'm going to move on to get it all aligned. 2 angle plates bolted down to the mill table there. I've got some heavy duty C-clamps to help hold it, and then a couple of strap clamps to clamp it against the angle plates there as well. And I'm just going to be using, you see I've got this drill stuck down in that hole there, and I'm just going to use that to just visually align that up and down. But if you look, you can see it with your plain eyes that this is not in the center of that bore right there. I mean that, let me see, I'm going to, something like that. It's off center a little bit. So that's not even in the middle of the bore, but we want to just try to get that hole up and down, and then we're going to use our shaft here to find the center of it, and then once we do, we'll just drill and tap where it makes sense in the center of the bore there, our new hole. But anyway, that's our setup there. Just wanted to give you a good visual of that. We've got my stand there that's holding the weight of the drum until I get it leveled where I want, and then we'll clamp it down nice and tight. We have the drum here where it needs to be. I got the shaft in there. We're going to use this to align the bore there. So now I need to go ahead and rotate the turn around on the mill. You have there's 4 bolts here that you have to loosen. 2 here, 2 on the other side. That's the shin splitter right there. Get that out of the way. So crack those 4 loose. I find that it's easier to rotate it where it sits versus pulling it out, then trying to rotate it around. Just got to move this no-go because it's trying to stretch the lines there. Set it over there out of the way. Just get it kind of lined up. That looks pretty good right there. Then you have these 2 bolts that tighten up on the dovetail up here. Loosen those, and then here's your rack. Just make sure you don't pinch any of those lines. That's all the way out right there. It's further than what I wanted it. That's going to be an issue right there. The last time that I worked on this, it was a half because they basically cut it in half and I wasn't as far out as I am. That's going to be an issue. So let me think about this, see what I can come up with. I can go back just a little bit more, but that doesn't really help me with the travel. Not good to be right up on the ways there, but it looks like it's going to be pretty darn close. I think we might be able to get it though. Let's move this down some. Right about there. I sure wanted to get lined up on the shaft out there, and I don't know if we're going to have enough travel to get out there. This is why it's sometimes difficult to get video during a project, because you run into these kind of issues like this. But I'm showing you what it's like to have to work on a job where everything isn't quite obvious. So let me do some more thinking on our setup here, and we'll show you where we're at when we get it figured out. During this part of the job, I failed to ensure that my microphone receiver was turned on, so I got a few clips here showing the setup that I actually didn't catch any audio. So we're just going to kind of walk through this and do a voiceover and see if we can explain what we're doing here. All right, so we've got the shaft installed in the drum, and I've got a Noga holder in the collet, and I've got a Starrett back plunge indicator, the number 196. And what we're doing is we're ensuring that the shaft is aligned in the y-axis, because I'm going to use the back side of the shaft that's sticking through by the angle plates to find the center of the bore so that we're in the proper center when we do our drilling for the set screws. So I've already kind of bumped it around at this point, just kind of showing you how straight it is, but we loosened up both of the angle plates so that they can move, showing the clamps there. Just loosen those up so you can bump the part around and get it aligned. This is a little bit better close up, just showing how close we are. I was well within 1/1000th the amount of travel that we could move it in the y-axis there, which is plenty close enough for drilling and tapping a set screw in something like this. So now that we have it aligned, we can go back there and make sure that our two angle plates are tightened up down to the table so it doesn't move. And now that that shaft is sticking through the back side, we can use that to locate the center of the shaft so that we can be sure that we're in the center of the bore. So I believe we're going to move on to that part of the setup next. What I have is a 3/4 inch rod. That is a Thompson hardened and ground. It's turned ground and polished rod, so it's pretty darn straight. I didn't indicate it, but it's probably well within a couple of thousandths if you stuck an indicator on the end of that. And what we're using that for is to transfer the spindle down to the shaft, because I can't get all the way down there with an edge finder. Now, if I had some kind of long tool holder, we could stick an edge finder down in there, but since I don't have a tool like that, we're just going to do it like this. You can stick a rod in the spindle, bring it down next to your shaft, turn the spindle on, and I'm going to show you just a simple technique that you can use to find the center of this, using a piece of paper and just very gently moving the table in X over against the shaft until it tightens up on the paper that I'm showing there. And once it gets snug on that paper, you know you're going to be within a couple thousandths on the edge of that shaft. Again, plenty close enough for the job at hand and what we're having to do here. So we'll get a little close up of using this technique to find the edge of the shaft. This is just a little closer shot showing what we're doing, the rod down there next to the shaft. And what we'll do is turn the spindle on, let that shaft rotate, or let that rod rotate, and you can feel it in the paper once you come up next to the edge of that shaft, and it'll actually get tight. It's so smooth that it doesn't actually want to pull the paper through like it would with a cutter, but once it tightens up where it just kind of fixes that paper in position, you know you're on the edge of that shaft. So here we are running the spindle, and I'm just moving the paper up and down, because obviously there's a gap there, and once you fill that gap up where it's next to the shaft there, it'll get tight on the paper like so, and then you know you're on the edge of the shaft. At this point, just simply retract and move the table in X the proper amount that you need to, which is half the diameter of the shaft and half the diameter of that rod that we're using. And right there, we're in the center of the shaft. Where we're at now, I'm going to spot it. So I have just a standard 1/2 inch diameter jobber drill, and all I'm going to use is hopefully make a nice straight divot right there with that, because I don't have a long center drill that I can use to make a divot. So we're just going to go with the drill. We're going to drill and tap it for 3/8/16. We're going to drill the hole oversize down a length of about 3 inches, and we're going to leave the last 1 inch the material that we'll be running the tap down through there. All right, so let's go ahead and get our spot. Just come down nice and gentle, let the center point of the drill do its work and get centered up. I feel like it's doing it there. I don't see it trying to walk. So that should be good right there. We got our little divot. And now we'll go in with a long drill. Actually, we're going to start with the shortest drills possible and get a hole established in there, and then we'll have to put our long drills in there to get all the way through, because we have to get, since we're next to this flange, this is what really holds us up, because the collet chuck is going to be up here. You got to have enough reach to go from here all the way down through the bore there. Okay, we've got a standard 3/8 jobber drill in the spindle. We're going to use some of our anchor lube to help us get this done. All right, here we go. Again, we'll just drill this hole as deep as we can get it there, and then we're going to switch it over to our long drill. Right about there. All right, here's our long 3/8 diameter drill. I've got it marked with a Sharpie here, or a paint marker, I mean, on the depth at which we need. This is 3 inches, and the way I've calculated is from this surface down to the bore is approximately 3 7/8, using a scale to measure everything. So if we go down 3 inches there, it should give us about 7/8 thickness there that we can tap. So we're just going to drill it with this, and then we're going to go in there with a 5/16 drill and drill it our tap size. This is just our clearance hole, and I may have to put another drill in there to open that hole up just a little bit so that the set screw can slide down in there nice and easy. That should be pretty good. So you can see how much further we got to drill there. And we'll go ahead and we're going to put some of our anchor lube down inside that hole there. See if we can get them to break off. All right, I think we got it. Yeah, we got it there. All right, we'll take this out, and then we'll go in with our tap size, 5/16. Okay, we've got our 5/16 long drill installed in a collet there. Now we can go ahead and finish our drilling. I'm gonna go ahead and take our anchor lube and just squirt a little bit more down in there. And we'll see how she does. You got to be careful with these long drills that you don't overload them. They will bend and flex on you. It's working well. There we are. That looks good. So we're going to go in there with a 17/32 drill to open it up, and we have to do that, but this is the tap driver that I made the last time we did this job. So this is a 1/2 inch diameter piece of drill rod, and I've got that machined with a couple set screws so it'll hold that tap there. And we need the clearance to be able to go down through there and clear this and those set screws. So that's why last time I used the 17/32. I got it marked there where we need for our 3 inch depth. So put this in a collet and go ahead and open up that hole as needed. Put a little bit of lube in here. That should be it right there. Yep, we're good. Now we can tap it. We take our adapter. You see we got clearance down in there. All right, we'll set this guy up. We'll do some hand tapping. I wanted to show you guys what we're going to be using to tap this. So this is the extension that I machined the last time I did this job. It's a piece of 1/2 inch diameter drill rod. I have it drilled and bored on this side to fit a standard 3/8 tap. We have 2 set screws drilled and tapped in here, 180 degrees out opposing, so that it will tighten down on the flats or the square of the tap, and that's what drives it. On this end, I have it milled for a square so that you can put a chuck wrench on here. And this is the way that I'm going to be tapping the hole. Now you can certainly power tap this. You can put this in a collet, and this is the tap we're going to be using. This is a Cleveland 3/8/16 spiral pointed tap, or also known as a gun tap. Slide this down in there, and you can tighten up these set screws here to drive on the square of the tap. I'm just getting them, just go ahead and get them snugged up there. Okay. All right. So yes, you could certainly power tap this, but for me personally, personal preference, there's a blind hole. It's a long reach. You can't see what's going on down here except for when the tap comes through. So I've only got a couple of holes to tap. I'm going to hand tap this. That's just the way that I'd rather do it, and go off of the feel of this in this tap wrench, and you can feel it in your hands and your fingers. And you can tell when that tap is coming through and whenever the pressure releases, versus power tapping it and risk something going on and snapping the tap off. So anyway, that's the tapping setup. And then what we'll use also, I have this spring-loaded center, 1/2 inch diameter shank, and it'll just push in that center that I've got drilled in the end of that. And that's what keeps everything nice and straight while you're hand tapping it there. All right, we got our spring center in there. We're gonna put some of our lube here on our tap. And we need to move it down to 0. There we have it. We are ready to tap. The tap feels good. Cutting just like a new tap should. I can tell that it's about to come through. And now we've come completely through the hole. There we have it. Just about to come out of the set screws there. You can see you still got anchor lube on it. Everything worked great. Beautiful job. One last thing we need to do is deburr the top of that hole. I'm not going to fuss with a chamfer tool. We're just going to use our Noga deburr tool right here. Just break that sharp edge off there. I'm trying to get it to where I can get it in my hand well. Perfect. That's all it needed. A little touch of the Noga. And we have one side completed. Halfway through the job. So we're halfway through the job. Everything is working out well with all of our drills and everything. We had just enough room on our turret here to be able to get out here and get this done. So I'm not going to fuss with a bunch of videos setting this up a second time. You guys have already seen what I've done, but just to break it down quickly, I'm going to put some support underneath there. We're going to loosen our clamps, rotate it 180 degrees. We'll put our shaft back in there, make sure that it's indicated, find the center of it. I've got a distance from this flange to the center of the hole that we're going to copy on the other side, make sure it's the same, and just get through the setup of this, get it done, and then once we get that finished, I'll focus on giving you guys some more, drilling and tapping action of this part. But I'm happy with the direction that it's going, and everything seems to be working out really well. We just finished getting the second set screw hole drilled and tapped. Everything worked out great. There was no issues, no problems. I'm happy with it. Job well done there. Only thing left to do is get it out of the machine, a little bit of cleanup, and then we've got our set screws that we need to put in there as well. I was looking in my little set screw set here, and we have a couple of these 3/8/16 1-inch long set screws in there. This is what we'll install. We'll put some anti-seize on them before we put them in there. But that finishes that up. So we'll get it out of the mill, and then we'll move over to the shaft and the worm gear, get those guys cleaned up so that we can get this job finished up. All right, let's finish off this cable winch drum. All we have left is we're going to install our set screws there. So we're going to give it a good coating with our CRC anti-seize. We don't want the whole bottle on there, we just need a little bit. A little bit more than a little bit, but I don't think it's going to hurt in this situation. These get used in marine applications. All right, one more to go. Well, that is going to wrap up the cable winch drum. The work is complete. We've got both of our set screws installed. We've got our bore cleaned out, got our keyways cleaned out. It is ready to go back onto the shaft. So our work on this guy is complete. It is ready to go. Next up, we're going to get back on our shaft and our worm gear here. This is the next phase of the work that we need to get completed. I'm going to get these keyways cleaned up where it had sheared the keys and it deformed the shaft. It's got some really high spots on there, making it very tight going inside the gear. So we need to get those cleaned up, get this back to a 2-inch journal, and then we're going to machine 2 new 3/8 keyways on here, 180 degrees apart, and make sure the bore is cleaned up in the gear there as well. And that'll be the last thing that we need to do, is get the keyways milled on the shaft there. So this is what we're going to go ahead and jump on next and get started on that.